Welcome to lesson 13. Have a go at this in your own time. Obviously pause the video, see you back here in a sec. Right. Oh, this is the trick. We've got two things multiplied together that make 0, which means one of the two must be 0. So either 3x plus 1, either thing on the left, equals 0, or x minus 2 equals 0. So we can just stick a little or in there, maybe. I mean, I always think the vertical line just means or anyway. So I'm going to minus 1 here, so it gives me 3x equals minus 1. Then I'm going to divide by 3, which gives me x equals minus 1 over 3. And then here I'm going to add 2 to both sides, so x equals 2. Oh, well, that's it, done. And now I'm going to stick an or in just to make the answer complete. A couple of thoughts. You might be saying, how would I know to do that? Well, as we talked about in the last lesson, and as I did in the bonus lesson for last lesson, we're going to just start building the skill of spotting what to do. So, yeah, maybe I am making this a little bit awkward compared to other teachers, but we're training ourselves. For example, I always say to my students, in the exam, they're not going to hold your hand and tell you exactly what to do. Well, it depends on the exam, but often they don't. They often just give you a problem. And there's no context. It's because in a maths class, often the teacher says, today we're going to study blah, blah, blah. And the moment they've said that, I always think they've made the learning less valuable because you're already reducing the ability for you to learn to identify things because you've already been told in advance what it is. Anyway, blah, 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 blah. Second little thought is, did you get that one wrong? If you did, please be careful. Notice I'm putting things in circles and very systematically, slowly, one step at a time working through the equation. And by doing that, I'm avoiding a lot of potential little mistakes. Let's do another solve. Surprise, surprise, we've got another solve. Okay, have a go in your own time, then I'll see you back here. And the answers are x equals minus 2 or x equals minus 3. So, in case you're already comfortable with that, you can move on. What can we do? Oh, look, we could simplify this bit. So that would be x plus 5. I always think if you sort of spot something to simplify, just simplify it straight away. Because there's now less things, so that's going to be a good thing. Remember we said we don't like fractions, do we? Remember I said fractions generally a bad thing. So as a rough rule of thumb, let's get rid of fractions if we can. How do we get rid of this fraction? We times by 3. So that gives us x plus 5 equals minus 6. Remember what the other thing was? I said, well, generally I don't really like this. I like to get rid of it. I said, I don't really like brackets. In general-ish. So in general-ish, I'll get rid of them if I can. So I'm just going to multiply out those brackets. Let's do that in purple. So it gives me x squared plus 5x equals minus 6. So now the next thing is we have to go, oh, what do I do now? Oh, I've got an equation. I've got an x squared and an x, which is two different types of thing. Only one equation. Oh, in theory, this can't be solved. Oh, wait, let me just check. Because if it's an x squared and an x, sometimes I can use that trick thing, can't I? Oh, it looks like I can. Let's try it. I'm going to add 6 to both sides. X squared plus 5x plus 6 equals 0. Yeah, we're on to a winner. This looks great. So I'm going to go x plus 3, x plus 2 equals 0. So I'm going to say I've got two things multiplied together that make equal a 0, so one of them has to be 0. So either x plus 3 equals 0 or x plus 2 equals 0. So I'm going to minus 3 from both sides here, which means x equals minus 3. And here I'm going to minus 2 from both sides, which means x equals minus 2. So we've got that, all that. There you go. Now, if you watch the advanced introduction, like the more technical introduction to this series of 20 lessons, I touched on something about how I have this 5-step approach to solve any equation. I'll just write out what I just said. 5-step approach to solve any equation. I like to teach this to my students. I've chosen not to teach it in this course of 20 because I want this to be complementary to my maths book with its associated over 100 videos. So I thought I'm going to be just taking a slightly different angle, emphasizing different things. Anyway, if you're interested, you think, oh, this sounds interesting, well then go and check out my book, which is, remember, the ebook's free, and check out the associated videos and you can learn a bit about that approach. Anyway, let's do the next question. That is an A, a B, and a 3, in case you're wondering. Have a go in your own time, and the answer is not possible. Because B is an unknown, A is an unknown, so there's two unknowns, but there's only one equation, so it's not possible. That's a 6, by the way. It's supposed to be a 6. Have a go in your own time. Right, the answer is k equals minus 6 or k equals minus 1. I'll show you how I did it. Okay, so the first thing I did was I said, there's no fractions, no brackets. There's an equation. Oh, there's two different things. I can't. Oh wait, can I use the trick? Yes, I can. So I'm going to factorize. It's going to be a k and a k. How do I make 6? Well, it could be 1 times 6 or 2 times 3. Well, I know what 2 times 3 looks like already. When it's 2 times 3, it's always a 5 there, isn't it? Not a 7. It's a 7. Oh, wait a sec. I can kind of intuitively see how that's going to work. So if you wanted to do it, you could now multiply this out. Let's just test it in red. That's k squared plus 6k plus k plus 6, which is k squared plus 6k. No, it's not. Whoa, I just said it wrong. So 6k plus another k makes 7k plus 6. Bingo, that worked. I'm now going to draw a line down. I'm going to do it in a different color and draw a line down. So either k plus 1 equals 0 or k plus 6 equals 0. I'll minus 1 from both sides here, which means that k equals minus 1. I'll minus 6 from both sides here, which means that k equals minus 6. Bingo. I know I'm going quite fast. Remember, if you're like, oh, Duncan just slid away from the answer straight away, you can always pause the video. I have to kind of balance the fact that some people are just kind of impatient for me to carry on at some point. Okay, so solve. Notice there's a comma. That just is a comma separating two different equations. So have a go in your own time. There's two equations there. Equation 1, equation 2. So maybe we can solve this. There's two unknowns and two equations. Let's have a go. Oh, wait a sec. Look at this. That's something divided by something equals 0, which means the thing on the top has to be equal to 0. So we now know that a equals 0. Bingo. Now let's do the other one. So that means we've got 0 plus b equals 3. So b equals 3. Sorted. There we go. So that's the solution to that one. Make. Can you guess what the rest of the question is going to be? M the subject. Have a go in your own time. Okay. I want m on its own. So I'm going to minus 1 from both sides. Then I get 1 minus x equals, 1 minus x minus 1 equals 1 plus m minus 1. I'm just going to put a plus sign in front of that and a plus sign in front of that. Look, I've got a plus 1 and a minus 1. I've got a plus 1 and a minus 1. So the plus 1 and the minus 1 cancel on this side, and on this side the plus 1 and the minus 1 cancel, which means I've got minus x equals m. I'm just going to write it around the other way, so m equals minus x. That's the final answer. Let's do the next one. Pause the video, have a go in your own time. And if you just saw the screen jump, that's because I made such a mess of explaining this question. I've had to kind of rewind and start again. Now, pause the video, have a go in your own time. I might have already said that. We're going to use by inspection. I don't know what cohat means. Do you know what it means? I've got no idea. It doesn't matter what it means. Well, it might do because it depends on whether it's got one-to-one relationship, blah blah blah. But we're just going to ignore that. If you don't understand what I just said, it doesn't matter. It's just in case we go, oh, but wait. Anyway, here's the thing. Basically, we could just the thing inside cohat presumably has to be the same because otherwise the equal sign can't be true. So let's just roll with that. So now we can just solve it. What should we do first? We want all the x's together. Oh, by the way, the answer ends up as being x equals 2. So if you're kind of happy that you got x equals 2, it's all good. I'm going to minus x from both sides. Let's look at y. X plus 3 minus x equals 3x minus 1 minus x. Over here, we effectively have a plus x and a minus x, so they cancel, which just leaves a 3. And here we've got a plus 3x and a minus x, which makes a plus 2x. Let's not bother with the plus, minus 1. Now I'm going to change colour again. Let's add 1 to both sides. So that means we get 4 equals 2x. Then we divide by 2, which gives us x equals 2. Ta-da! There we go. Let's do the next question. I've got a set of 4 simplifiers for you, so wait until I've written all 4 out. And obviously it may not be possible, so if you think it's not possible, write not possible. What I'm just writing here is a letter P. That's supposed to be a letter P, okay? That's supposed to be a letter Q. Again, a P and a Q. Have a go in your own time. I'll see you back here in a sec. The answers are, I'll just quickly write the answers down. So obviously you can jump with the timestamps onto the next question if you wish. I'm going to explain these a bit. Let's just explain this one first. X squared is x times x. So that's x squared there. And then the next bit is x cubed, x times x times x. Oh, what's x times x times x times x times x? Well, that's x to the 5. So now I'm just going to jump straight to this one. Oh, right, so x to the p is just x times x, blah, 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 times x. There's going to be p of them. And then we're going to have x times x times x times x times x. And there's going to be q of them here, which means we effectively have, let me just move that line. We can actually have p plus q's worth of, anyway, there you go. Maybe that makes sense. This one here, that's x times x times x times x times x divided by x times x. Oh look, I'm going to do some cancelling in a different colour. Cancel, cancel, that leaves us with x cubed. Wait a sec. There were 5 x's on the top and 2 on the bottom, and 2 of the x's on the bottom cancel with 2 of the ones on the top. So I can write this one here as p minus q, because it's going to be p of them on the top and q of them on the bottom. And once I've sort of finished cancelling, there'll be p minus q remaining. As usual with my lessons, the idea there is that we got some addition, we got some thinking, some ideas, ways of thinking, just to help you understand what's going on. I always think you just need to get exposed to enough people explaining it, doing enough examples on your own, sleeping on it, doing it the next day, sleeping on it, doing it the next day, and then eventually these things start to make sense. And I've known subjects where I struggle with something, and then a year later it makes sense to me. So sometimes there's a lot of patience. Right, here we go. Have a go. I've finished writing them all down. I'm going to write the answers down, then I'll talk about them. There we go. Skip to the next question if you like. I'm going to talk about it. Remember, the 1 doesn't matter because 1 just means it stays the same. And the minus means flip. So all I've done is I've turned the fraction upside down. Again, here the 1 doesn't matter. The minus means flip, so I turn it into a fraction by putting a 1 underneath. Then I can flip it and makes it a third. Again, the 1 doesn't matter. The minus is a flip, so I just flip it. And 8 divided by 1 is equal to 8, because I don't need to write divided by 1. This one, I can't scribble out the 2, because the 2 means something. So, first of all, I'm going to do the flip, which gives me 3 over 1, but I still have the 2 remaining. I haven't dealt with that yet, so I've got to leave it there. Before I do anything else, I'm just going to write that as 3, because I know that 3 over 1 is just 3. Oh, and 3 squared means 3 times 3, so the answer is 9. So just to emphasize again, we've got x to the minus p over q, just to use p and q. Remember, the minus means flip, the p is a power, and the q is a root. It's just a question of being systematic and just plugging away, following the instructions in the power, and eventually getting to the right answer, or correct answer. Another bunch of calculates. By the way, there's a bonus lesson with some more calculates if you want some extra practice. I just wrote that really messily, didn't I? I'm just going to do that again. So I'll just write all these. I'll let you know when I've finished. And I'm done. Have a go in your own time. Then I'll write the answers out. Then we can talk about it. Minus 1, 1/6, 3 over 2, 2 over 3, 6, 3 over 2, 2 over 3. I'll talk about, obviously skip to the next question if you want. I'm going to talk about it now. Talk about the first one. That's minus 1 times minus 1 times minus 1. Minus 1 times minus 1 is just 1. 1 times minus 1 is minus 1. When you multiply fractions, you multiply the top by the top, the bottom by the bottom. So that's 1 times 1 divided by 3 times 2, which is where that comes from. Remember, that's just 3 over 1, so that's 3 times 1 on the top and 1 times 2 on the bottom. This one is 2 over 1, so that's just 1 times 2 on the top, 3 times 1 on the bottom. This is, well, it's just 3 times 2. This one here, well, remember that divide, oh, what does divide mean? It means exactly the same as this, or this. So we can just write this as 3 divided by 2. Oh, look, there you go, that'll do as the answer, won't it? You might have written 1.5. I mean, that's correct. I didn't specify how to give the answer. This last one here, I think in an earlier lesson I said, oh, we'll just do this once, I won't do it again. Well, I seem to have done it again. Well, whatever. When you divide a fraction, you can rewrite it as, oh, I don't like dividing fractions, that's too difficult. I'm going to change it into a times sign. And magically, that works if I just flip the second fraction over. So that'd be 2/3. So that explains that one. Because remember that 1 times 2 on the top and 3 times 1 on the bottom. Let's look at the next question. It's a plot, which I'm going to change into a sketch, because when we do sketches, we can just do it roughly, and I'm lazy. And remember what I said before, that if you're at university, often you get sketch questions, and then if you do it really neatly with a ruler, you lose marks because they're like, no, because mathematicians don't waste time if they don't need to. But you might be in an exam where you do need to use a, or in a situation where you do need to do it. Oh, by the way, I've written all of them out now, so you can like pause the video anytime you like. I'm just setting up my axes so I can draw my answer out. Okay, I'll draw the answers, and then usual routine, you can skip to the next question or watch me waffle on about it. I'm not totally happy with this one in the middle. I'd rather it was flatter. When it says sketch, you've got to make a reasonable effort to make it look good. Right, so let's just talk about them. I'm going to talk about this one in the middle first. Oh, look, for every single point, the value of x is different. So obviously this must be that straight line where y is the same. And of course y is the same, and I'm going to write a 3 there just to prove it. to show that that's 3. Here, there's no markings on the axes, so we have to assume the markings are correct. In which case, well, maybe that's 1 and 1, and maybe that's 2 and 2. The point being that for every point on the point being that every point on this line has x and y equal to the sort of same value. Maybe that's minus 2/3 and minus 2/3. Who knows? The x squared. Now, remember, if you're not sure, draw a table. Draw a table. Please, 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 please draw a table. I always say to my students, it doesn't actually take very long, and you just stick some numbers in. Just do one number at a time. So I'm going to pretend that I don't know what this graph looks like. Let's just rub it out. Okay. What if x is 0? Then y is 0 squared is 0 squared. I'll do some rough working here. It's 0. Okay, so I can mark that point. What if x is 1? Then y is 1 squared, which is, that's 1. Okay, so I can mark that point. What happens if x is 2? 2 squared, that's 2 times 2, which is 4. Okay, so that'll be 4, so I can now mark that. So x is 2, y is 4. What if x is, I think I know what it is. I'm going to jump to minus 2. Minus 2 squared is minus 2 times minus 2, which is 4. Because minus times minus is a plus. So that means I've got a minus 2 here. Yep, I'm happy. Now I can draw it in. Notice what I did there. Some students, I'm just going to show what some students do, and I think it's mainly because they've been taught early doors by a teacher to do this, and then it never really gets properly explained to them. You don't have to do this all the time. A lot of students go, oh, well, I'm going to do 1, 2, 3, 4, 5, and 6. Please don't do that. It's really inefficient because you spent ages. Imagine we'd done this for this. You would have just ended up with loads of points and it would have been a mess, and some of them wouldn't even fit on the graph, and you still would have no idea what's happening on the left. I mean, if it works, if doing the big table like this works for you, I guess keep doing it. Maybe you found a way to make it work. But in theory, it should be a lot quicker if you just pick one point at a time and immediately plot that point. Oh, I did 1 point, then try, and then eventually you'll be happy. And my top tip if you're doing this is please do at least 3 points. Because, let's just rewind. Rewind. I'm going to pretend that I picked the number 1. I'm waffling on a bit here. Then x squared is 1. There's 1 point. What if I pick minus 1? Minus 1 squared is 1. I've only done 2 points, and I've seen students do this. Oh, I guess it looks like that. No, you need more than 2 points just to get a better idea of where it's going. Right, enough waffling. Let's do the next question. We can do another calculate question. Again, remember I've got a bonus lesson with a bunch more calculates if you want to do a bit more calculating practice. There's 4 of them here. I'll write them out, then you can pause the video, have a go. Have a go in your own time. And these are the answers. If you're not sure why, I'll talk it through. We're just minusing something from itself, so that's why that's 0. This, anything like 10 divided by 10 is 1. 2.3 divided by 2.3 is 1. X divided by x is 1. Root 3 divided by root 3 is 1. So something divided by itself is 1. Here, remember the elephants. What's one elephant? What's elephant plus elephant? It's just 2 elephants. There you go. So what's root 3 plus root 3? 2 root 3. And this last one up here, remember we've done some patterns, haven't we? We've done things like what's root 25 times root 25? Well, that's 5 times 5, which is 25. Okay, so that's fine. What's root 9 times root 9? That's 3 times 3, which is 9. And eventually we kind of spot the pattern and we go, okay, I'm comfortable with this. If I do the root of a number times the root of a number, I end up with that number. If I do the root of a number times the root of a number, I end up with that number. Let's do the next question. This is a function question. Again, I'm not actually going to ask a question. I'm just going to give you a situation just to work through. Oh, look, the screen jumped slightly again. Do you know what? All the videos were going so smoothly and this one's been a bit of a nightmare. Okay, let me try this one again. I'm going to write out a bunch of things like usual for my function question. And then the challenge for you will be to fill out the blank. So that box there is the blank. That's what you need to fill in. Work out what goes in there. Pause the video. See you back here in a minute. And the answer is x plus 1. Notice that's a G, that's a G, that's a G, that's a G, that's an H. So the H is not relevant to this question. Why is x plus 1? Well, 2 plus 1 is 3. Minus 5 plus minus... Minus 5 plus 1 is minus 4. 100 plus 1 is 100 more. Yeah, that works. Brilliant. And x plus 1 is x plus 1. Let's do the next question, which is a factorize. Have a go in your own time, and then I'll write out the answer. And it is 7x plus 1, x plus 1. That's the answer. Skip to the next question if you like. Otherwise, I'm going to have a go at sort of talking you through how I'd do it. So let me just scribble out the answer. Let's just delete the answer. So I'm going to look at this. This is how I'd do this one. Needs to be double brackets. It's going to be a plus in each. I mean, sometimes there's like minuses, but here I've got 2 pluses, so I guess it must be 2 pluses. Oh, this is easy. How do I make 1? 1 times 1. That's great news. How do I make 7x squared? It's going to be an x. Let's just change colour for this one. How do I make 7x squared? There's going to be an x. Here's the thing, x times x is x squared. So I need a 7 in front. How do I make 7? There's only one way of making 7 because it's a prime number. It's only one. So I guess one of them must be 7x. The other one's x. Because 7x times x is 7x squared. So that looks promising. Let's just check it. Let's just check our up. Oh, don't scribble out working. That's bad. Okay. So that's 7x squared plus 7x plus x plus 1, which is 7x squared plus 8x plus 1. Bingo. That worked. Excellent. Let's do the next question. It's another factorized question. Have a go in your own time. And I'm going to talk through how I do this. The first thing I do when factorizing is I look for something that I can take outside. Oh, they've all got an x. And you can multiply that out if you like and check, and that definitely works. And the second thing I do is, and then I repeat the process, so I have another look. So is there anything else in there that they share in common? No, so I can't do anything else. Then the next thing I do is I say, can I do double brackets? Oh, I can do double brackets. So now that's going to be x. Oh, we've done this one so many times, we know what this is by now. And then obviously I see if I can do this one again. I can't. And then that's the end of the process. So to me, factorizing is always a two-step process. More about that in my book. Remember, the ebook's free and all the videos are free. Check out the other playlist on my YouTube channel. And I find this two-step factorizing process is extremely useful. I'm just going to tell you why. Because this is why I find it's useful for my students. If you're in an exam, they very rarely say, please factorize this, brackets, it's a blah 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 type question. They don't usually tell you, they just say factorize. So you know when you're at school or whatever, and it depends on your teacher and depends on the syllabus, depends on what stage you're at in your learning. So it totally depends. But often you know in advance what type of question you got. But in the exam you got no idea. They don't help you. They just say factorize. So this is getting you used to the idea that you can. I'm trying to write and speak at the same time. It's very difficult. It gets you used to the idea of being in an exam, not having anything beyond the question in front of you, meaning you have to kind of deduce what to do. Right, when can we ignore brackets? Sometimes we can ignore brackets. I'll let you know when I've finished writing. So there's going to be a few of these. Have a go in your own time. You might be thinking, I don't know what the question means. What I mean is, I'm going to do the first one myself. Can I scribble out these brackets? Meaning, can I ignore them? Can I just pretend they're not there? In this case, I can. That's fine. Because it's just a bunch of things added together. Putting the brackets doesn't change anything. Right, so if you now understand what to do, maybe pause the video again. I'm actually going to jump straight to the only other one where you can do it, and then we'll just talk about the others. In this, where it's a bunch of things all times together, you can also ignore the brackets. But in every other situation, you have to deal with the brackets as they are. So in this one, in this one, in this one, this one, and this one, the brackets are very important. You have to take them into account. Why is it important? In the first one here, it's because you've got a minus sign, so it has to minus the x and the 2. Here, the times sign has to act on both of them. Here, there's actually a times sign, so those are exactly the same thing. Here, there's a divide, so everything has to be dividing. If you remove the brackets, that's not happening anymore. And here, the brackets are important because the square is acting on the brackets. So to recap, there are two situations where you can ignore brackets, where everything's added together or everything's timed together. Otherwise, if it's a minus or a times or a divide or a power, blah, 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 then you can't. Oh, that was it. That's the end of this lesson. See you in the next video.